Alright, so in the last video, we talked about what is the point of trig ratios. I do have to apologize. That should have been titled 10.6b. 10.6a you did an assignment on where you were just practicing your SOHCAHTOA and trig ratios. 10.6b was where we really talked about how to solve right triangles. So today, we're doing 10.6c. And the question for the day is, why do we have to do another section of 10.6? And to help answer that question, I have a challenge for you. And that challenge is, pause this video and see if you can solve the following right triangles. Okay, again, I don't know if you really paused and unpaused there, but we're back. And remember, what does it mean to solve a triangle? It means I know this and I know this, but I need to figure out that, and I need to figure out that, and I need to figure out that. And on this one, I know this and this, but I need to figure out what that is, and I need to figure out that angle and that angle. And if you tried to solve either one of these triangles, you might have had an interesting adventure. For the first one, I think we were able to do it. So you had 90 and 40. This had to be 50 degrees right here. We would be able to do, for instance, so let's do sine of 40 equals opposite over hypotenuse, b over 18. So we just have to do 18 times the sine of 40. And 11.5 seems pretty reasonable right here. Roughly, I guess it would be 11.6. Okay. And what would A approximately be? I could do the same thing. I could do sine of 50 as opposite over hypotenuse. I like using sine. No, not 50, 18. Right? Sine of 50 equals opposite over hypotenuse. So I'm now going to do, instead of 18 sine 40, I'm going to do 18 sine 50, and that'll come out slightly different. So it's about 13.8. And boom, in a matter of just a minute or two, I solved that whole right triangle. However, when we get to this triangle, we got a problem. I can figure out what this missing leg is by just doing a squared, b squared, c squared, which, by the way, should work here as well if you want to double check these answers and see, does this squared plus this squared roughly equal that squared? It might not come out exact because of the approximation and the approximation, but roughly this squared plus this squared should equal that squared. Over here, I would do y squared plus 8 squared is 19 squared. So 19 squared is 361. I'm going to subtract 64 and get 297 is whatever y squared is. So when I unsquare that, I get y is approximately 17.2. Looks reasonable, so I like that answer. But we kind of come to a screeching halt when it comes to the rest of this. How do I find the measure of angle x? And how do I find the measure of angle y? On the previous problem, I knew this and this, and I could use the 180 rule to find this, but all I know is that this is 90. So I don't know, is this 45 and 45 to make the other 90 to make the full 180? Or is this maybe, I don't know, 30 and 60 and 90 adds up to 180? Or could this be like 10 and 80 and 90 makes 180? I'm just guessing. And I'm stuck. And if I really want to solve this and get the actual answer, I need something better than just guessing. So I'm going to zoom in on this triangle a little bit here. Same triangle, same problem. We decided that this side right here, this missing side, here, should I put it this way, is about 17.2 roughly. Okay, but Our problem is we still don't know the measurement of angle x or the measurement of angle y. Something I do know about angle y is this. I know that the sine of angle y would be opposite over hypotenuse. I know that the cosine of angle y would be adjacent over hypotenuse. I know the tangent of angle y would be opposite over adjacent. But how does that help me? Well, guess what? I could do this division, and instead of using the angle to find the ratio, could I find the ratio to find the angle? Yeah, but how? Should I just sit here on my calculator all day and go, well, okay, 17.2 divided by 19 is about 0.9053, and I'm just going to try different angles. Is the sine of 1? Nope, that's not 0.9053. How about sine of 2? Nope, that didn't work. How about sine of 18? Nope, that didn't work. How about sine of 38.314? Nope, that didn't work. And I'm just going to sit here and try different angles until eventually I stumble upon... That sounds terrible. So here's what we're going to do. We are going to use something called the inverse trig ratios. And the inverse trig ratios are going to be very, very helpful in solving a problem like this. Inverse trig ratios. We know what an inverse is. It's kind of like doing the opposite of something. So I'm going to instead of signing this angle to get the ratio, I'm going to unsign the ratio to get the angle. Unsign the ratio to get the angle. So let's take this, bring it down here, and I'm going to say that I'm going to take that ratio and I'm going to unsign it. I'm going to inverse sine it in order to get the angle measurement that I need. So this is what's called the inverse sine. Okay, sine with a little -1. It's like the inverse, the opposite of sine. It's unsigning. Or sometimes you hear it called the arc sine. And what do you know, but on my calculator, above my sine and cosine and tangent, if I look really carefully, I've got a little sine -1, cosine -1, and tan -1. And that means I can do this on my calculator. So on my calculator, I'm going to hit second or maybe shift on some of your calculators. And then I can put this decimal, or I could just put this ratio if I wanted to in there, 0.9053. And guess what it's going to spit out? Y is about 65 degrees. And if I look at this, does it seem like this could be about 65 degrees? That seems pretty reasonable to me. And now I've almost solved the entire triangle. I have all three sides. I have two of the three angles. And guess what? The last part is easy. I just have to use the 180 rule to find angle x. 180 minus my 90 degree right angle minus my 65 degree angle right there gives me 25 degrees. Now, at this point, it's probably a good idea to check your work. How could I check my work here? Let's do something like this. Theoretically, the sine of 25 degrees would be what over what? Opposite over hypotenuse. So, let's calculate this on my calculator, calculate this on my calculator, and see if it works, and see if we did it right. 8 divided by 19 is about 0.4211 roughly, and the sine of 25 degrees is, well, okay, is it precisely correct? No, but is it close enough? Yes. And why isn't it precise? Because was this exactly 65 degrees? No, if you remember, I kind of rounded this. And if I rounded this, then that means I rounded that. And so this isn't exactly 25 degrees, but it's pretty dang close, enough to know that I have basically solved my right triangle. And I did it using the power of inverse trig ratios. I used the inverse sine, or the arc sine, but guess what? You can do the inverse cosine or the inverse tangent. And just to show you that over here on my calculator, if I do the inverse cosine of 8/19, I should still get 65 degrees, theoretically. Let's test it out. Inverse cosine of 8 divided by 19. Ah, there it is. Okay, let's try inverse tangent of 17.2 divided by 8. 65 degrees. So you can use arc sine, arc cosine, arc tangent, inverse tangent, inverse cosine. You can use any inverse trig ratios now to solve any right triangle, even if it's one of these ones that's a little bit tricky and painful. And that's basically what you need to know for section 10.6. So why do we have to do another section of 10.6? The answer was you didn't know how to solve this one without inverse trig ratios, and now you know inverse trig ratios, and now you can solve any right triangle in the entire universe using some combination of the 180 rule, a squared b squared c squared, and sine, cosine, tangent, and inverse sine, cosine, and tangent. So hopefully that's real helpful. You're going to do some more practice problems for section 10.6. I promise this is the last that we're going to do of section 10.6 and trigonometry, and that's actually the end of chapter 10 as far as we're concerned. So one more assignment in chapter 10, solving some more right triangles, and then we're going to review everything we've learned in chapter 10 about roots and radicals and triangles and trig and Pythagoras and all that good stuff. So thanks for coming along for the ride. Best of luck, and I will catch up with you later.